Alright, in the last video we were introducing potential energy and conservative forces. And we went over the formula for the change in potential energy, which is the negative work done by a conservative force will equal the change in potential energy. And that negative sign means that if a conservative force does negative work, then the object will increase in potential energy. So our ball in the example down here, when we raised it up, gravity did negative work on the ball, but the ball gained positive potential energy, right? It gained potential energy. And when we were thinking about what it meant to do negative work, right? If I do positive work on something, I transfer energy to it. If I do no work on an object, I don't transfer any energy to it. And if I do negative work on an object, really, that object is transferring energy to me. Now, if we extend that to this, if gravity is doing negative work, it's really meaning in some way the ball is doing work on gravity, which seems a little weird and shouldn't make sense. But that's where the key to what a conservative force is. Now, if negative work is done on a conservative force, that energy that's being transferred to that force is really gained as potential energy, right? And that's why we have this negative sign here. It's saying that if you do work against this force, right, that means that the force will be doing negative work on you, and by doing negative work on you, it will cancel out with this negative sign to give you a positive number for the change in potential energy. So let's kind of just compare this to some non-conservative forces for some insight. So let's say I'm pushing a box, and I'm pushing it with whatever, like 10 newtons of force over 1 meter. It can be 1 kilogram. And let's say that while I push with 10 newtons, there's some gravity, right? So it's kind of on the surface. And say gravity is exerting a force of negative 3 newtons, right? So negative because it's pushing against me. Friction always makes it harder for me to push things because it's going against me. And so if I wanted to find the work done by me, it would just be the force times the distance, 10 newtons times 1 meter. But the work done by friction would be negative 3 newtons times 1 meter. And so you get 10 joules up top and negative 3 joules on the bottom. And this negative 3 means that in some way the block is transferring 3 joules of energy to friction, right, in some way. Now, with gravity, when we transferred energy to gravity, right, when gravity did negative work, we gained potential energy. I said, well, if I let go of that ball, we would see that energy come back because it would fall kind of all by itself. Now, if I push a box, right, and I accumulate all of this kind of negative work done by friction, I never get any of that back, right? I can't be like, oh, well, I did all this work against friction, so now the box will slide itself for a while, which is kind of what we saw with gravity, right? If I take a ball from point A and I raise it to point B, it gains potential energy. And we can see that potential energy be converted back to kinetic energy when we let it fall, right, all by itself. We also see this if you have a spring, right, and we push down on the spring, and then the spring is all compressed, right? The spring went this way, so the distance is this way. The force we did was this way, the force of me. But the spring is pushing up, right, and you could feel that resistance. So in pushing down the spring does negative work on us. And if the spring's doing negative work, we're really gaining that work in potential energy. And that's why we would fly away. If we compress the spring, we'd bounce up. And that's kind of how like a springboard or like a trampoline would work.